I'm going to try and come in. Hi, welcome to Kitchen Chemistry, Kitchen Science. We're doing some chemistry today. So we're going to have a look at the reaction between acids and carbonates, which is a base. So I've got ethanoic acid, and if you were doing this at home, you can use vinegar. And I've also got sodium bicarbonate, which again is like sodium bicarbonate of soda that you can get when you're making cakes. So this is a really easy practical that you can do at home. In my conical flask, I've got about 150 mils of my acid, and then I put my bicarbonate into a balloon. There's about 4 or 5 tablespoons in there, mainly because I want to try and get quite a lot of carbon dioxide. So what I'm going to do is I'm going to upend my balloon so that my bicarbonate reacts with my acid. And when acids and carbonates react together, you get the metal salt. So in this case, it's going to be sodium ethanoate, water, and carbon dioxide. And carbon dioxide is what we're looking for. And we're going to try and test that carbon dioxide with my candle. Now, because carbon dioxide is a heavy gas, when it's filled up my balloon, I'm going to try and collect it in my bucket. And once we've collected enough, I'm going to try and pour it, because it's a dense gas, it sinks. I'm going to try and pour it over the top of my candle. And because it's going to reduce the amount of oxygen around the candle should hopefully go out. So what we are going to do now is react my bicarbonate with my acid. Now there's quite a lot of bicarbonate in here, so I have to give it a good shake. And hopefully we'll get a good balloon full. Okay. You can see actually the reaction is so big it's gone all the way into my balloon. So I'm going to try and wait for that to subside. Sure that we don't lose any of our carbon dioxide. I'm going to twist it off. Oh, that was a pop. And then I'm going to try and collect my carbon dioxide in the bottom of my bucket. Now I'm releasing it really slowly so that it doesn't escape out of the top. And the reason that I can do this is, like I said, carbon dioxide is a dense gas. It sinks. Just as my balloon out slowly, hence the little delightful noise it's making. Just to see if I can get any more carbon dioxide. I might not be able to now because the reaction might be over. Because one of my reactants will be limiting how far the reaction can go. Year 10, limiting reactants, remember? See, I've got a small amount of carbon dioxide still being produced. And that reaction is over. So what I'm going to do again is try and remove my balloon and just collect that last bit of carbon dioxide gas. Now my carbon dioxide shouldn't go anywhere because it's a dense gas. It should be sitting at the bottom of my bucket there. So I'm going to take a candle. I'm going to light my candle. I don't know if you can see that, but my candle is lit. So, having lit my candle, I'm going to take my bucket and I'm going to try and pour my gas over the candle. And theoretically, because carbon dioxide is a dense gas and we're reducing oxygen around the candle should go out. So we're just going to have a go and see if that happens. Well, it seems like I didn't actually collect enough carbon dioxide gas because we're still lit. But if I had collected enough, I would have managed to put the candle out. The reason I might not have done that is because there's an awful lot of air within this beaker. So a lot of the air would have been displaced into the balloon. And it might be that the amount of carbon dioxide that we got wasn't quite enough anyway. But it's a good practical for you to try at home, because it makes a really big fizz, and if you put it inside like a put a little bit of washing up liquid in there and put it inside a tube and a little bit of red food colouring, you can make it look a bit like a volcano. So if you wanted to build a volcano and do a bicarb and vinegar volcano, that's the way that you do it.